Hello, Math Studies students. Welcome to another online lesson. Today we'll be continuing our discussion of the chi-squared test for independence, and specifically we'll talk about the steps for the formal chi-squared test for independence, what we have to do to actually test if two variables are independent of each other, and we'll also talk about the actual results of our chi-squared equation and interpreting those. Not going to do a whole lot of actual math today. Quick review, we have our chi-squared formula. If you need any assistance on how to use that, you can refer back to our video from last time. You need to do expected values. We'll talk about this next time, but this takes us to our formal test for independence. So chi-squared, the official name of the chi-squared test is the chi-squared test for independence. And so when we use the chi-squared formula, what we're trying to find out is, are things independent, meaning they do not affect each other. I've given a few examples, but we could talk like gender and grades. You know, if they pass the chi-squared test, then one's gender does not affect how well they do in school. If they fail, that means there is a relationship, and one's gender does affect how well they do in school. And we could talk about all sorts of things like that. Another one might be like gender and height. Does one's gender affect how tall they might grow to be? And maybe that one we would find that it does pass the, that it fails the chi-squared independence test, meaning that there is a relationship and gender does affect how tall you are. Again, these are examples of categorical variables that we could check out using the chi-squared test for independence. So to start with, just like in the science class, we have to state our hypothesis. We have something called a null hypothesis. It's abbreviated H sub 0, so it's not an O there like observed data, it's an actual 0. And we call that the null hypothesis. On your test, they might just say write down H sub 0. That means state your null hypothesis. This is a statement that the two classifications or categorical variables being considered are independent. So we could say, we had an example from last class that was gender and sleep, and we could say our null hypothesis, there is no relationship between gender and sleep. Or you could say gender and the amount of sleep you receive are independent of each other. So either way, either say no relationship or independent, because that's what independent means. The alternative hypothesis, that is H sub 1, and this is a statement that the two classifications being considered are not independent. So that would say something like gender and sleep are not independent, or there is a relationship between gender and sleep. That's your first statement. You write down your two different hypotheses, your null hypothesis and your alternative hypothesis. And again, they're almost always the same sentences. You're just putting in your different categorical variables. That leads us to step 2. Step 2, we calculate what is known as degrees of freedom. Now, back in maybe Algebra 2, you probably did some studying with R and C. That may ring a bell as rows and columns. So for degrees of freedom, and that's what DF stands for, all you do is you take the number of rows that you have minus 1 times the number of columns that you have minus 1, and you multiply those together. So again, the example we had last time had 2 rows. There were 2 genders, male and female, and then there were 2 columns representing getting enough sleep or greater than 8 hours or less than that. And so again, we put in the 2 for the columns and we subtract those. 2 minus 1 times 2 minus 1, well, that's 1 times 1, which would equal 1. So our degree of freedom would be 1. Next, we quote the significance level required, 10%, 5%, 1%. It'll be one of these 3% that you'll be asked to use. It's always given to you, meaning in the question, it'll say test at a 5% significance level. That's the most common one that we use, but they could say 1 or 10% as well. We just state it. We say we are testing at a 5% significance level, and we move on. And that is step 3. Step 4, we state the rejection inequality. Inequality is something involving a less than or greater than or less than or equal to sign or something like that. So rejection means we will reject our null hypothesis, meaning it fails the test, meaning they're not independent, if our chi-squared value is bigger than some number k, where k is obtained from the table of critical values, and we'll get to that. So this is just a statement that says we will reject our null hypothesis if chi-squared is greater than some value, and we would write that number down. Step 5, from the contingency table, find chi-squared. That is what we did last class. We just calculated chi-squared. You need your expected values, your observed data from the table, and all that stuff. There should be a squared symbol there, and so on and so forth, chi-squared. Step 6, we either accept or reject our null hypothesis depending on the rejection inequality result, meaning we compare our chi-squared to our critical value, and if chi-squared is bigger than our critical value, we reject it. If we reject, that means there is a relationship because we didn't pass the chi-squared test for independence. Think of it like golf. If we want to pass the test, we need the smallest score possible, lowest score. And I mentioned golf only because that's one of the few sports where you want a low score, the lowest score possible. Again, to pass this test, lower score is what gets it done. If you're bigger than your critical value, you fail the test. And we reject our null hypothesis. I mentioned earlier our critical values. We'd have to select that from the table. This is from your book on page 338, and it has different measures of degree of freedom as well as different significant levels that we can test at, the three that I mentioned earlier, 1%, 10%, 5%. And on our last little run through, I said that we had a degree of freedom, or a DF, that equals 1. So you would go to the degree of freedom with 1, and let's say we were testing at a 5% significance level, then I would find where these two columns match up, and my critical value would be 3.84, meaning that if I had a chi-squared value less than 3.84, I would not reject my null hypothesis, and we would assume that they are independent. If I had a chi-squared value that was greater than 3.84, I would say I reject my null hypothesis, and therefore there is a relationship between my two variables. Now let's say I had more rows and columns and I came up with a 4 and I was testing at a 10% significance level. Let me use a different color here. Well, then I would follow this one over and this one over, and if my chi-squared value is less than 7.78, I would pass the test of independence, meaning there's no relationship. And if I got a value, chi-squared value that was higher than 7.78, I would say there is a relationship between those variables. So that's the idea. So let me quickly run through one last example here involving chi-squared. So in a small town of Joinville, population 1,000, an election was held. The results were as follows. We have two candidates, candidate A and B, and then two sets of voters, urban and rural. Urban meaning in the city, rural meaning outside the city. Complete the formal test for independence with this data at a 5% significance level. So the first thing we want to do is we want to state our null hypothesis. So step 1, null hypothesis, and that would be there is no relationship between we could call this candidate selection or candidate choice. Candidate selection and where the voter lives. Our alternative hypothesis would be there is a relationship between, and I'm just going to put ... just for the sake of time. So there is a relationship between candidate selection and where the voter lives. So it'd be the exact same sentence, except I would take off the word no to say that there is a relationship. That was our first step, null hypothesis. Second step, I believe, was degree of freedom. So I say, how many rows do I have? Well, with data, I have 1, 2 rows here. How many columns? 1, 2. So my degree of freedom would be equal to rows minus 1, so 2 minus 1, times columns minus 1, 2 minus 1, which becomes 1 times 1, which is 1. Next, I state, I believe, give me one moment. Yes, I would state my critical, or sorry, my significance level that I'm testing at. So we just say something like, I will test at, and in this case, it was a 5% significance level. 5% significance level. All right, so those are the first 3 steps done. Step 4, we write down our rejection inequality. Say, I will reject my null hypothesis if my chi-squared value is greater than my critical value. Now the critical value I need to look up on that table, and since I've written all this stuff, I'm not going to erase it all right now, but if you go back to the previous slide, we look at our degree of freedom, which was 1. We're testing at 5%, and then you can find the critical value, and it was 3.84. So I will reject my null hypothesis if chi-squared is greater than 3.84. On to step 5. Step 5, we actually do the chi-squared test. And I did my work ahead of time. And if you want to do yours as well and then double check it, but I got a chi-squared value. And sometimes you'll see them write chi-squared calculated, meaning that we figured it out. And chi-squared is equal to 7.97. In this case, 7.97. After we get our chi-squared value, our 6th step is we compare, and chi-squared of 7.97 is greater than 3.84. So therefore, I reject my null hypothesis. Since my chi-squared value is greater than the critical value. Critical value of 3.84. Therefore, there is a relationship between, and I'm out of room here, but between our 2 variables, which were, if we go back to our alternative hypothesis, there is a relationship between candidate selection and where the voter lives. And again, it's good just to restate that because that's what we actually found. So it's sort of like a science lab in that you're actually, in addition to doing the math, you're doing a write-up, a formal write-up. You're stating what you originally expected to have happen. We're showing why we're doing the things that we're doing, explaining our results, and then, again, actually specifically stating whether or not we accepted or rejected our null hypothesis. I will give you a handout next class that will not only walk you through doing a formal test for independence, but it will also, on the back, have those rules that I just went through on the previous slide. So in the book, we have a few problems that you could look at as well on page 337 and 341. And I will get you a worksheet for next time.